Radioactivity, today we'll be looking at the spontaneous emission of radiations from the radioactive elements. And the emissions we're talking about here is the alpha particle, the beta particles, and the gamma radiations. We know that basically all naturally occurring elements that has an atomic number greater than 82 are radioactive in nature. So when we're talking about the disintegration, we talk about the laws of disintegration. The laws of disintegration. One, the emission of these radioactive radiations is spontaneous. It's spontaneous. The reaction is spontaneous. It means that no one initiates the reaction. And this is accompanied by the emission of the alpha, the beta, and the gamma radiations. Number two, it takes place at random. It is at random. Number three, the number of atoms that disintegrates per second is directly proportional to the remaining unchanged radioactive atom present at any instant. And that is where our interest is. If N is the number of atoms present in the radioactive element at a time t, and the N is the number that disintegrates within a small interval dt. So we'll now talk about the rate of decay. The rate of decay, the N minus the N dt, is directly proportional to N. This decay during a small change in time, the t, and is directly proportional to the number of atoms present in the radioactive elements. The question is why minus? Once this disintegration takes place, the elements, the number of atoms keeps reducing. The number of atoms keeps reducing. That is why we have minus here. And we know that we don't work with this proportionality constant. We need to have this as minus the N, the T, equal to minus lambda N. And where lambda is what we call the radioactive decay. Where lambda is equal to radioactive decay. So our interest here, remember we have minus here, equal to lambda N. So we can rearrange this equation and say that the N, the T, is equal to minus lambda N. Remember, we have minus on the left-hand side of the equation, and on the right-hand side we have this. So if you decide to multiply through by minus, minus times minus becomes positive, times positive becomes minus. So we can also rearrange this and say that the n equal to minus lambda n dt. We can also write something like this. And we'll put it the n all over n equal to minus lambda dt, which we can express as 1 all over n, the n equal to minus lambda dt. So with this, we can integrate 1 all over n, the n, equal to minus lambda, which is a constant, dt. So from here, integrating this, we'll now have ln n, or we can write it as natural log of n. Base 2 means the same. So we can choose any one we want to work with. So we can say that ln n is equal to, this is a constant, minus lambda. If you integrate the t, you have t plus this. So this is our equation 1. We have arrived at this point where we don't know what is c. It's a constant of integration. So we need to look at it. So at this point, we say let n equal to n naught and t equal to 0. So if you substitute these parameters into the equation 1 becomes ln n naught equal to, if you substitute the value of this becomes, the whole of this becomes 0, because anything multiplied by 0 is 0. So we have equal to c, we have n naught equal to c, and that will be our equation 2. So in this case, substitute equation 2 to equation 1. We now have, at least we have known the value of what is c now. We have ln n equal to lambda t plus, we now substitute this value, ln n naught. So we can collect like terms. We can collect like terms by taking this to the left hand side, and it become minus. So we now have ln n minus ln n naught equal to this. Remember, this minus lambda t. This is where we did the substitution, so this should be minus. So from the laws of logarithm, when we are subtracting, we divide. So this becomes ln n all over ln n naught equal to minus lambda t. From the laws of logarithm, we have this. So we can also express this as ln n all over n naught equal to minus lambda t. So by taking the natural log on both sides, this becomes n all over n naught equal to e minus lambda t. So when we rearrange this equation, we now have n equal to n naught e minus lambda t. This will be equation 3. This equation is very, very important as far as radioactivity is concerned. Many of you have been saying this, but you don't know how it comes about, how it is derived. So at this point, we have derived this, and in our next class, we'll go into the application, how we can use this equation, how we can use this to calculate so many things. Thank you.